So very good morning all. So today we are going to discuss about the topic electrical missions. Okay, so in the DC missions we have the topic starters. Okay, so in the previous sessions we have discussed about the speed control of DC motors. Okay, so speed control of DC shunt mission, DC series motors. Okay, so voltage control method, flux control method and armature control method that we have discussed. So today we are going to discuss about the starters. Okay, so in this sessions we are going to deal with that. So next first we will get the of starters. Okay, so we are going to deal with the necessity starters and types starters, and then we go for 3-point starter and 4-point starter and 2-point starter. Okay, so 3-point, 4-point, 2-point starters we are going to tell. Okay, so let we start. So here first necessity of the starter. So we know the DC missions. Okay, so let me take the back EMF. Okay, so back EMF of the DC motor. Okay, so that is is equal to, okay, 5NZ by P into 60 into A. Okay, 5NZ by 60 into P by A. Okay, so so we having the EB, that is a V minus IA RA. Okay, so where IA is equal to V minus EB by RA. Okay, so this value no. So the IA, okay, so IA current we have depend, right? So when motor, okay, so what will happen? So here we have to discuss that. So when motor at rest, back EMF, okay, so when motor is rest, so back EMF developed in the armature is 0. Okay, so that is where IA is equal to V minus E, right? We are right. So IA is equal to V minus EB by RE. That is voltage, supply voltage minus back EMF by RE. So at that time what will get? So at rest of position, so we'll getting the EB is equal to 0. Okay, so that is we'll get the V by RA. Okay, at initial position. So at that time what will happen? Suppose if you take the case, so if we are supplying the voltage, that is 230 volts DC, and so here the armature resistance, if you having the armature resistance, if you having the 1 ohm. Okay, at initial the current flowing through the armature, that is IA is equal to 230 by 1. Okay, so that is 230 amperes is flowing through the armature at initial. So when rest position, that is back EMF 0. Okay, due to that what will happen? So more than 10 times of current is flowing through the armature. Okay, so here armature resistance will have only 1 ohm, so it cannot withstand the 230 amperes of current. Okay, so to avoid the excessive current at initial C, we need the starters. Okay, so to avoid the excessive current, that is 10 times of excessive current is flowing through the armature. Okay, so to avoid that of current, so we need the at initially starting purpose we need the starters. Okay, so armature will draw the heavy large current at initially, right? So here such large current may result in the damage to the armature, sparking at brushes over the commutator. Okay, so deterioration of the insulation due to the overheating. So these heavy currents, this will having the, so 230 amperes of the initial current, so that will goes to the damage the armature and heavy sparking at the commutator. Okay, so whatever the commutator is there, its brushes. Okay, so this will having the some insulation around that. Okay, so micro insulation also placed in between that. So if it is 230 amperes is flowing, okay, so machine's ratings will having the 22 amperes to the 30 amperes ratings also there. Okay, so if it is 230 amperes of flowing, so these mica insulations may fail. Also has the armature, okay, so the armature insulation also is failed. Okay, next another, that is insulation. So deterioration of the insulation causing the overheating. Okay, this may be effect in the, well, starting of the DC motor. Okay, so due to the heavy current flow, if it is back EMF, so at initial, so we didn't get the back EMF, so that's why we'll get the high currents. To avoid this excessive current, we need to use the starters. So to avoid the excessive current, so a resistance is introduced in series with the armature. This resistance is known as the starter resistance. Okay, so during the starting period only, that is about 5 to 10 seconds. Okay, so we are going to placing that is 5 to 10 seconds only. So these will limit the starting current to safe value. So these will values, that is here a resistance, so at the initial the current will having that. Okay, so V minus EB by RE. Okay, if it is RE is AB is 0, at that time we'll getting the V by RA value only. Okay, at that time, so high amount of current is flowing that, right? So these high amount of current will resist to damage the armature. So to avoid this one, so we are placing the resistance. Okay, so we are placing the resistance in series with the armature. Okay, so we are placing the in series with the armature initiation. So the resistance introduction in series in the armature, this resistance is known as the starter resistance. So this resistance is called as the starter resistance. So during the starting period only, that is 5 to 10 seconds only, we are placing. So these will limit the starting current to the safe value. So what will have these resistance which are placing, that is the series resistance we are placing, that will limit the starting current to the safe value. Okay, so that resistance known as the starter resistance. So as the motor gains, okay, so what will happen, so after motor gains the speed, starting resistance will cut off. Okay, so as the speed, this starting resistance, because here after motor gains speed, so what will happen, back EMF induced in the machine. Okay, so that, okay, so then back EMF is increases and regulate its speed, so the starting currents limit to the safe value. So we are casing the example, that is 440 volts 5 HP motor which has armature resistance 0.205 ohms. So full load current, so the motor rating of that is we have the 50 amperes. So at that time, at initially, okay, if it line directly, so it will draw the starting current of, that is we are having value, so 1760 amperes current will flow in. That is we are taking, that is IA is equal to V by RA, right? So here V is equal to 400 volts 0.25, okay, causing 60 amperes, okay, at initial to the line. So this will cause the damage to the armature. So which will having the higher, okay, so 35.25 amperes, okay, which is higher. So that's why we need to, this excessive current will blow out the fuses and damage to the armature winding, so and committed. Okay, so that's why we need to avoid the starting resistance. So R is connected to the in series with the armature. Okay, the starting current is limited to the safe value. So here the value of the starter resistance. Okay, so here the armature current is having the 400 by 0.25. Okay, so plus R, so from that when getting the, that is 50 amperes. So then the resistance, how much resistance we have to connect it, that is 7.75 ohms. Okay, so from this equations we get the how much resistance we have to place in series. Okay, that is 7.75 ohms. So this R is called starter resistance. So if you observe the resistance, so that will having this. So depend upon the motor ratings. Okay, the resistance will be varied. So for in case of small motors, so very small motors may be started directly without the starter. Such motor having the high armature resistance than large motor. For small motors will having the large resistance, hence starting current is not high. Okay, that's why we are not using the for small machines low moment of inertia, hence they speed up quickly. Okay, so as well as the armature resistance is high for the small motor, so due to that it will not required for the starters. Okay, so types of starters. So we have the starters, that is which type of connections is there. Okay, so the flash plate of the box type starter used for the starting shunt compound motors ordinary industrial capacity of the two kinds. One is 3-point starter and 4-point starter. Okay, so this is the 3-point starter. So remember these two uh, we will talk about the that is shunt and compound motors only. We are using the 3-point and 4-point. So and so suppose if we are using the series motor, then we have to using the 2-point starter. Okay, this is also another type. So 3-point starter, shunt, compound, okay, and 2-point starter we can use the for series motor. Okay, so this is the type. So this is the so this is the 3-point starter. We can see having the starting resistance. Okay, so this is the start resistance which are connected to brass. Okay, so and here we are having the lever, that is off position to on position, and we have the E and M. We are having the coils, so we are having the 3 points, that is A and C. So here we can write in the practical we will have armature and field. Okay, R line, armature, Z. Okay, so in case of Z or F we can see in the panel boards in the practical. Okay, so we are having the spring balance. Okay, so we are having the not a spring balance, so we are having the spring inside the at lever. Okay, so let's discuss what will happen. So RS, so this is the RS, you have the starting resistance, L is the moving arm, and S is the soft iron piece. So E is the, okay, this E is the no load no voltage release, and M is the overload release. Okay, and ABs are the starting terminals. Okay, just to see. So this RS, okay, this RS is the resistance. Okay, so L will having the moving arm. Okay, this soft iron, S is the soft, so this E will having the no voltage coil. Okay, this is the no NV coil, no voltage coil. So this is the overload coil. Okay, M is the overload current. Okay, so ABC, this ABC, that is I can write line, field, and armature, LZA. So line, field, and armature current. Okay, so these are the starter terminals. So here we can observe this is the resistance, RS is the starting resistance, and this is the moving arm, this is the soft iron which has have to attract to the no voltage release, and it is moving, that is so only with at initially that will goes to the, so slowly we will start by using this moving arm, and so the current will flowing through this one. Okay, so here the starting whenever connect to the this supply, so that will current is flowing. So we can see the So suppose here if we connected, okay, the current is flowing through this the resistance, okay. So from that the armature will flow, okay, as well as here the splitting which take place, that is when connected this with the, okay, if it is connected then the resistance path will take place here the armature, okay. So from that we will having the field, okay, that will be connected and okay. So this is the RS, and from that from the E, okay, so no voltage coil to will having the, that is armature field will connected, okay. So whenever the voltage, okay, so any fault is occurred, so when the motor is overloaded, okay, at this, so this overload coil, okay, no voltage coil overload coil will be used. So we can observe, so ABC is the starting terminals, on line directly connect to the arm armature terminal, and one field terminal which is connect to the tie. So that is we are talking about the, so L, so A is the line, field, armature. So on line is directly connect to the one armature terminal, okay, one field terminal which are connect to the tie. So we can see here, so that is one line correctly, so that is connected here, and another line to the field. So as the mode, as the other line connected to the point A, okay, this other line which is connected to the, that is L, so connected to the L moving arm, okay, so that is connected to the moving arm, and through the overload M is released. So when any loads overloads occur, so that will be release the coil, so this attraction will be take place. So to start the motor, main switch first is closed, that is this is the main switch will closed. So this main switch is closed, then it will be start the motor. So as soon as the arc makes the contact to the one, so the field current, okay, the field circuit is directly connected to the across the line. So we can observe, so as the same time full starting resistance R is placed in series the armature. So as soon as R makes the contact with the line, so first if we connected, then current is flowing through this one. So at that time, so the current is, these terminals will flow through the here. So this will be connected to the line, that is E point. E point నుంచి ఏంటంటే ఇక్కడ మనకు ఫస్ట్ ఫీల్డ్, ఓకే, సో ఫీల్డ్ కరెంట్ అని ఫ్లో అవుతుంది, ఓకే. సో ఫీల్డ్ కరెంట్ నుంచి అనేది ఇది ఎనర్జైజ్ అవుతుంది, ఓకే. సో ఎనర్జైజ్ దెన్ ఎట్ సేమ్ టైం, ఓకే, ఫుల్ స్టార్టింగ్ రెసిస్టెన్స్, సో మనం ఫుల్గా రెసిస్టెన్స్ స్టార్ట్ చేసినాం, సో సిరీస్ ది ఆర్మేచర్, సో అప్పుడు కూడా ఏంటంటే టోటల్గా ఫుల్ కరెంట్ అనేది ఇక్కడ ఫ్లో అవుతుంది, ఓకే. సో ఎట్ ఇనిషియల్ లో కరెంట్ మాత్రం ఫ్లో అవుతుంది, ఎట్ ఫుల్ కరెంట్ విల్ బి ఫ్లో. The starting current drawn by the armature, that is I is equal to V by RA plus RS, okay, where RA is the armature resistance, R is the starting current, reducing the starting current, connecting series with the resistance, okay, with the armature. So as the arm is further moved, the starting resistance is gradually cut. So if we is the running okay, the arm moves. So what will happen, so let's see here, as the arm is further moved, the starting resistance gradually cut. So if it is at this position, okay, it is connected at this time, so that is full resistance that is connected to the this one. So if it is connected, okay, so for 10th point, so what will happen, that current will be flowing through the this one, so the current is flowing this path only, so throughout the resistance path. So the arm moves over the various steps against the strong spring. That is here ఈ పొజిషన్స్ పొజిషన్స్కి రావడానికి ఏంటంటే మళ్ళీ బ్యాక్ రావాలి. ఓకే, సో ఆ పొజిషన్స్ ఏంటంటే సో మనకి ఎప్పుడైతే అనేది ఆఫ్ చేసాం అనుకో. ఓకే, సో ఈ స్ప్రింగ్ బ్యాక్, ఈ స్ప్రింగ్ ఏదైతే ఉందో సో స్ప్రింగ్ అనేది బ్యాక్ వాళ్ళని తీసుకొస్తుంది. ఓకే, బికాస్ ఒకవేళ ఈ స్ప్రింగ్ అనేది ఫెయిల్యూర్ అయింది అనుకోండి, సో అప్పుడు ఏమవుతుంది, ఇలా ఈ పొజిషన్స్లో మాత్రమే ఉంటుంది. ఓకే, ఓకే, సో మనకి ఈ పొజిషన్, ఓకే, ఈ పొజిషన్స్ ఏదైతుందో సో మనకి ఇక్కడ